All right, so good morning, everyone. We are going to resume our lecture on Lambda and streams, actually. You're going to hear me often name this module, functional programming, but just so that you know, we are still far from actual functional programming, okay? And our goal in this course is not to really go into the, like I said, the theoretical aspect or the purest aspect of functional programming. So really what we are doing here is more a Java 8, primer on Lambda expression and streams. If we have to be pragmatic, this is really what it boils down to, okay? So last time we discussed about, Lambda expression, how they are formed. Now we are going to start applying this to different basic use cases, okay? And I would say that most of, 90% of the time, those use cases are what you are going to end up using as an IT professional, okay? If you ever have to write some code, not necessarily in Java, but in any of the scripting language that enables, some form of functional programming, you're going to see that being able to leverage those techniques is going to make easy task even easier, okay? And that's the point here. So we are going to talk more specifically about transforming element this time. So let's take a look at this code here. So we have our friends list. So it's still a list of string. It's a final list of string. There's really no specific reason for that, okay? It's just that we are trying to get in the groove of not modifying states as much as we can. So many of those examples are going to kind of enforce that by declaring the data structures as final, okay? Remember, if you have to modify a list, it's better to rebuild a list and return it most of the time in terms of code cleanliness than to try to hack into the list and switch element around and stuff like that, okay? So here we have an array of names that is transformed into a list of names, okay? Then we want to transform that list and put all the names in uppercase. So we have another list, final also uppercase names. So we start with an empty list. And then we have here a for loop, traditional for loop. So this is an enhanced for loop. We iterate over all the names in friends. And for each name in friends, we cast it to uppercase, and then we add it to our uppercase name list that we're building. And then we display the whole thing, okay? So that's for enhanced for loop way to do it. Now, we talked last time about the for each method, okay? We talked about it in the context of, I think we already introduced streams last time. I'll have to double check, but it's also applicable to any collection. So you are going to encounter the for each method on streams as what we call a terminating method, terminator. You are going to also encounter it on collection. So it's just a way to iterate application of our Lambda on the collection. Very soon we're going to use map actually to do that kind of stuff. It's going to be a little bit better. But what we're doing here is we define our Lambda as you take a name, you call uppercase names.add, so you want to add something to that list that we're building, and then what you pass as parameter is whatever name was given to you, put it as uppercase. So name is going to be obviously an element of friends, which means it's a string, which means you can use all the methods that are defined in the class string. And once we are done, display the stuff. Question?
So this is the list, not the last uppercase name, then it will print through SOP?
So sorry, your question was uppercase name is a list? Yes, it is.
Yes,
but then
by just putting system or println we'll get only one element, or we'll get from there.
yes. So the question is, we can just system.out println a list and we get something actually readable? The answer is yes. Remember, when we talked about like good practices, when you want your class, like your class employee to be part of a Java collection, one of the good practice was you should always implement toString. Okay? Because the Java collection framework, when you ask a list, for example, to display itself, it's going to use the toString method of every element. So if you provide a nice readable toString method, then it's going to show nicely. If you don't, it's going to use the default object one, okay? Here we're talking about the list of string. So the job is easy, okay? The toString method for a string object is pretty trivial. So we can display in the collection, we can iteratively call, the toString and display the string, and that's fine. It's going to be readable, okay? When you pass things like that to system.out println, pretty much what happens is that the first step is to convert this into a string. So we may display it. So it's always related to the toString method. Yeah, you had a question?
Back to the previous slide.
Yep. So let's go back to the previous slide. Okay. Make sense? Okay. So that one is the enhanced for loop, right? So we just do everything by hand. I mean, it's better than playing with indexes, okay, but barely. And this is actually, we pass the lambda. So one of the idea here, because you were comparing, the previous slide and this one of the idea here is that this approach allows you to really focus your attention on what you want to do to every element. Okay, that's what the lambda captures. That's why people like this style of programming, because you are actually saying, okay, this is what I want to do to one element, and that becomes a unit of code that you can reuse, etc., pass around as parameter, do whatever you want to, and then you don't worry about the iteration anymore. You just say, okay, apply this to every element in my collection, and that's it. Okay? Yeah?
Like, what would be the advantage of using lambda for this example instead of using a simple for loop?
Well, the advantage of using lambda for this example would be exactly what I described.
Yeah,
okay.
You were telling I can go to each element and do update it or do
Okay.
what with that.
So hold on. When you ask, what is the advantage of using lambda in this example, one of the things I want to get out of the way is that you do not have to use lambdas. Okay. Because generally when people ask, why do I have to use lambda? What is the benefit of using lambda? They think in terms of something that was not possible before suddenly becomes possible. That's not the case, okay? Same thing with generics, we covered all of that, okay? So it's not that you cannot do your iteration the old way, even with indexes and stuff like that, okay? It's just that, again, like I said, the idea here is that it allows you to encapsulate into a unit of code, which is an expression and which is actually a function, what you want to apply to every element. And you encapsulate it into a lambda, which makes it quote-unquote portable. You can pass it as a parameter. You can have it as an argument. We're going to see a bunch of examples in the following slide where we try to reuse the same lambda for different, collection and stuff like that. We start generating lambdas from other lambdas and stuff like that. So it's mostly flexibility and I would say cleanliness of code. Okay, separation of concern. I don't want to have to think about indexes and iteration and calling, it.next and it.asNext, to know how to move into my collection. No, I just say apply this to each element of my collection. It's another level of reasoning about your code. Okay, that's the main advantage. So I would say it's mostly qualitative.
So,
Yep.
Lambda can only be used with the for each. Like if I have a lambda
No.
expression that has to be in a loop, I have to go for each.
No. So the question is, do we need to use the lambda only with a for each loop? No, not at all. We are going to use lambda for a lot more things. And there are many other actual methods that accept lambda expression as parameter that allow us to do all sorts of work on collection. And we are going to introduce very soon, actually more formally, the idea of stream, which is a way to handle a collection, in a manner that allows you, that facilitates the application of multiple lambdas in a so-called pipeline. Okay, so we're going to get to that in a few slides. Yeah.
Can you tell what would be this example if I use a while loop instead of for each loop? Can I use a while in this situation?
Yes, you can use a while loop if you want in this situation.
Now will it look like?
You would use an iterator. So you would define an iterator on your collection friend. Okay, and you would call, for example, if your iterator is named it, you would call it as next as a condition to know if you reach the end of your loop, then it.next to go to the next element of the loop, and then you would apply uppercase, to it, because that's your element, and you would write a loop like this. It's very, you probably did that in an undergraduate course somewhere, right? Iterate over a list of strings and do something like display the strings or convert them to uppercase. That's really not, there's no trap there.
No, I'm just asking like you just the example that you told about the iterator right now. It is using a simple thing. If I use it's not using a lambda function.
Yeah?
Yeah. So if I want to use while in lambda function, can I do it? I want to do that.
No, I don't see why you would use a while loop with a lambda expression here. That's the whole point. The whole point of using a lambda expression is that you are going to get away from using a for loop, a while loop, all of those things that require you to manage the iteration step by step yourself. So it's the advantage of Lambda expression is that you can pass them as parameters, right? So you are going to use methods like for each and stuff like that to which you can pass those expressions. Otherwise, you're shooting yourself in the foot pretty much. Okay, so sometime you are going to see the term internal iterator. Okay, so that's the term that's used here to describe this kind of process of iteration. All right, so an external iterator would be, for example, your while loop or the for loop that we had before, any situation where you are handling the iteration completely by hand. Now, there is one thing that we can look at improving in this example. Okay, we are trying to abstract ourselves from all the details, the tedious detail of the iteration, and that pretty much does it already for us, okay? Using that for each method and a Lambda expression as parameter. Now, the one thing that's still a little tedious in this example is our uppercase names list. Because we need to initialize it, we need to create the new empty list, we need to add every time to that list as we create new elements that are uppercase version of whatever was in France. So the idea is, can we actually go one step further? And since we have this one-time list that we pretty much create, populate, and throw away, is there a way for us to not have to manage the entire life cycle of this list? Okay? So that's going to be the next version of the code we are going to take a look at. And to go back to your question, yes, that's another example of where we are going to use Lambda and pass them to methods that are meant to accept Lambda and perform work with them, okay? So in this case, we are going to introduce two things. We are going to introduce a stream method that is defined on all collections, and we are going to introduce the map method. So what we are doing here, we are saying, okay, let's start with my collection friends. And I want to display an uppercase version of everything that is in friends. To do so, I'm going to create an intermediary data structure, and I'm going to apply a Lambda expression to that data structure. And then I'll pass this data structure pretty much element by element to system.out.print. Okay? So that's the same process, the same flow than we had on the previous slide. The main difference here is that the first thing we do is, instead of creating our own list that we are going to have to manage through its life cycle, we just say, get me a stream out of friends. So we take a collection, we generate what is called a stream. All right. And then we chain method calls. Okay, so the stream that results from the friends collection, so friends.stream, whatever is returned here, immediately I call .map on it. So the map method, which is something we are going to see a lot of and use a lot, okay, the map method is capable to take a stream and apply the Lambda expression that you specified as parameter to every element of the stream. So in this case, we have name as parameter for this Lambda. We take a name, so it's going to be one of the strings in friends, one after the other, and then we call two uppercase on that name, and we return an uppercase version of that string. All right? So map is doing the iteration for us, but it modifies the stream. That's the important thing. It takes as input a stream on which it is invoked, okay? And then it applies this transformation to every element and spits out as return value a stream of the elements that have been modified. So actually, when I say the elements that have been modified, be careful, because it's kind of an ambiguous statement. We do not modify the objects that are in the original stream. We do not modify the objects that are in the original collection. All we do is we take a string that was in friends, and we create a new string that is an uppercase version of it. And that goes into the resulting stream. And then after this, you see that I don't have a semicolon after map, because I keep chaining method call one after the other, okay? Some people refer to that as fluent chaining. So once I'm done with map, when map is done doing its part of the work in this pipeline that we are constructing, then the resulting stream, on the resulting stream, I call for each. And for each, again, is going to be one of those operations that iterate on the stream for us. So we are going to do a lot of that, okay? Give me a stream, I do something on the stream, pass it along, then somebody else does something on each element of the stream, pass it along, etc. The difference between map and for each is that map is an intermediary operation. We're going to see a few of them. That means that it takes a stream, does something on the element, spits out a stream. For each, in the context of stream, is a terminal operation, which means that after a for each, you should never have anything else in the pipeline, okay? Semicolon, you're done. This is the final thing you want to do on that temporary stream that you generated. So for each is going to take every element of the stream, take its name, system.outprint the name plus a space after it to display the result on the screen, okay? So that's a basic construction that we are going to see over and over several times. Question?
Yeah, sir, like instead of using a for each loop, like do I have a way of writing the system.out.println in the map only, like after it is converting the name to the uppercase, I just print it out on the screen and then go for the next name and then print it and convert it to uppercase and then print it out and then like this. Like can I pass two expression in the map?
Okay, so if the question is, can I write this differently? Yes. Can you write this differently with Lambda and do a good job? Probably no. You are trying to mix styles, okay? Your question all center around, can I do a while loop, can I do, etc. So,
No.
Well, I really don't know where you're going then.
Okay, like instead of using a for each loop on
Yeah.
the map, what I was thinking was in the map method only, in the braces, like after converting the name to the uppercase, can I just print it out on the screen?
Well, yeah, you could, okay, I understand your question now. So your question is, in that map, Lambda, can I do something added at the end that is displaying the element on the screen? This is really going away from everything we're trying to do here. Okay, we are trying to do things so that we limit side effects. So what you are proposing is, I want to make my Lambda here so that not only it converts to uppercase, but it also displays the result. If you do that, I don't see the point in using map at all, okay? Because you're not transforming a stream into another stream, right? You are taking a stream and you are displaying uppercase version of it. So remove the dot map line completely, do a for each, okay? And here, instead of doing system.outprint name plus a space, well, do system.outprint name dot to uppercase and then a space, okay? But then if you do that, then you can go further and you can say, why do I need a stream? So what you're doing is you are progressively going backward to the previous example. You see what I'm saying? Yeah, question.
Yeah, question. As I understood his question, so it's kind of, does stream implement to string in a fashion like list do? So can we call println on the stream without like, do not use last for each, but provide like, wrap all the map in the parentheses and put like println. Do you know this? No?
I'm not sure the stream actually offers you a println. Because if you put, let me make sure I understand, okay? If you put your map operation between parentheses and then try to call a println on the resulting object, you are calling pretty much on a stream, because that's what's going to result from your map operation, okay? Yeah. I don't think the stream defines println for the entire stream. Every time I've seen it used, it's always with a map. I mean, a map for a println would be a bad move, but you know, a for each or a terminal operation like this.
Yeah, and another question: does map perform lazily in this case?
We're going to get to that. Okay. So the question is, that map perform lazily? And lazy evaluation is one of the advantage actually that streams are going to get us, okay? So we're going to get to that like in a few, probably like next module or something like that, okay? But yes, that's one of the characteristics we're going to explore. And that's actually something that allows you to do things that are very interesting, like for example, potentially infinite streams, okay? In all the examples we're going to cover in this module, our streams are really a facade, you know, in front of a collection. We have a collection, we generate a stream, we do something on the stream, many intermediary operation, and then at the end we have like a terminal operation, like a for each, that displays things or write them in a file or whatever you can think of that is pretty much, okay, I'm done with that stream, okay, I'm going to take this data and do something about it. Do a computation, write it on this, write it on the screen, okay? So that's going to be like the structure we're going to repeat. But in all those examples, yeah, there should be this nagging thing about, well, all you are doing pretty much is generating a temporary, one or more temporary collections, okay? The same way in the previous slide, you know, we had this temporary collection that we populated with uppercase version of our string. Well, here it's done automatically for us with a stream, by the stream, right? But that was the point. The point is that we didn't want to have to manipulate that intermediary collection, that temporary collection, okay? We didn't want to have to handle its life cycle. So that's what the stream does for us. But in the last modules that we are going to have on functional programming with Java 8, you are going to see that you can go beyond that with streams. You can have actually streams that are procedurally generated, which means that there is some code that actually every time you try to go to the next element of the stream is going to generate that next element on the fly. And that's actually really interesting, because suddenly you can explore infinite streams, like for example a Fibonacci number series, okay? Just to take a very academic example. All right? So everybody on board so far?
Yeah, the map method, is it only for the stream?
Yeah. So good question. Is map only for stream? Yes. Map is one of those methods that come with the stream API, okay? Now the for each is a little bit ambiguous, because you saw that we apply here for each to a stream. So make sure you keep that in mind when you look at this example. For each is applied as a terminal operation on the stream. But we saw also for each applied directly to collections. So that method is defined multiple times in different classes, okay? So one of the things that I mentioned is the little pop-up window, but I didn't talk about it yet, is that the map operation has some particularities, okay? So by default, a mapping is going to keep the same number of elements. Now, there are times where what you generate with your Lambda expression in a map is going to be not necessarily one element for each input, okay? Maybe it's going to be, I want to filter, so I can generate 0 element given a name. Okay, or I can generate several elements, several new strings that have to be added, you know, to my stream based on one name. So if you are in those kind of situation, generally you want to use something called flat map. Okay, flat map is great when at some point you take a stream as input, and for every element of that stream, you may generate an entire stream potentially with 0 to n element, whatever n is, okay? So by default, if you try to do that with map, if you have lambda inside map that generates potentially a stream, you end up with a stream in which the element of that stream are themselves streams. And that can be, you know, difficult to process. So flat map instead allows you to say, well, if for every name in my input stream, you know, that comes from friend, if for every name you have 0 to n names you want me to generate as a stream, then I'm going to do so. But then I'm going to kind of concatenate all of those streams together so that the end result after your flat map call is going to be a single stream of strings in this example. Okay? So we'll talk a little bit more later, I think, about flat map. We're not going to use it that much. We're going to use basic, you know, mapping in 90% of what we do here, but I just want you to know that this exists. And another thing that you have to keep in mind when you first get started using map is that map, by default, is meant to keep the same data type. You don't have to. You can have like Lambda expressions that are going to, for example, take element from a stream of strings, like in our example, and spit out a stream of integer value. Like, for example, the length of each name. We're going to use that example very soon, okay? So it's just that there are some special cases, okay? There are some special cases, especially when you start dealing with primitive data types. I would say try to avoid dealing with streams of primitive data types. Streams are working best and in their simplest way when you apply them to Java objects, okay? So reference variable. If you have to use primitive data type streams as input or as output, we have specific streams for that, okay? So there are going to be things like, for example, an int stream. That, as the name implies, you know, it's going to be a stream of int values. So most of the time, I do believe that people go toward that kind of stuff for optimization reason. I haven't seen a reason really where using an int stream instead of a stream of integer is going to be really beneficial, okay? But those cases are actually accounted for in the Java 8 specification. So you have a bunch of streams for, I think, int, long, and double. These are the three primitive data types that are covered as string, and you have method that come specifically to work on those streams as well. So we are going to explore a little bit of that too later, okay? But I'm just giving you a heads up so that you have an idea of the dream use case, for map, which is pretty much what we're illustrating here. It's trivial. Give me one element, I spit out one element. Give me a string, I spit out a string. This is the simplest use case for mapping, okay? So now we have an example here of exactly not that, well, it's not a bad use case. I don't want to imply this, but it's an example of not abiding by those two rules, okay? So the easiest one for us to explore is the one about data types. The other one, like I said, we need to use a flat map method is different, but here we have an example, a simple example where we are actually mapping that stream coming from the friends collection of string, okay? And we map any name, any string in that collection to name.length. So we want to know how many characters are in each name, pretty much. So this is going to change, actually, the type of the elements we have in the stream, all right? So you get as input a stream of strings. You spit out as input a string of integers. So once you do that, then you can just chain out the next step in your pipeline, like the terminal operation, same way that we had here, okay? For each count is going to be displayed pretty much, and automatically you are going to have the type inference system recognize that count because it is applied to the stream that results from this operation, this step. Count is going to be actually an integer value, okay? So you can do things that are a little bit more, how to say, fancy, I would say, maybe. I don't know if it's a good word, but last step we're going to do, so we're not going to explore, changing the number of elements produced by the map. We'll leave that for the end. But another thing that we can still do on this example to try to simplify it is using method references. So what you see here, the syntax you see here, I already mentioned last time when we were trying to simplify our lambda, right? That was the last step in simplifying our lambda expression. Well, you can use that anywhere you would use a lambda expression. So you can inject method references in a map. All the map cares for is give me a function, give me a lambda. So anything that can be used actually as a function in that context, you can specify like this. So you don't have to rewrite lambda. I mean, we all do that when we start, writing Java 8 code. We write things like name, arrow, name.to uppercase, okay? But really, if you just take one parameter and pass that parameter to another method, well, you can write it more concisely and clearly by just saying, I want to call that method on every one of my elements in the stream, right? So that's what we have here. Now we are going to get into that, maybe not next slide, no, in a few slides. We're going to get into that into more detail because there are at least 3 different cases here that we are going to encounter. By the time we are done with the lecture, 4 of them, but it depends on whether you are referring to a static method, an instance method, or different types of method here. Yes,
so
question?
Uppercase also exists as a static method in string, yes? And here is a reference to the static method of the string.
It doesn't have to be a static method of the string. That's going to be determined by parameter routing. Yeah. Parameter routing is going to try to figure out, okay, first, do you have a static method, in string named to uppercase? Because if you do, then I pass, whatever element from the stream I have here, I'm considering right now, so whatever string I am considering, I pass it as parameter to the static version of to uppercase. But then, there's more to it, okay? Parameter routing means that maybe you have an instance method to uppercase. So if you do have an instance method in the class string, then obviously this instance method doesn't take any parameter. Like you can see here at the top of the slide, right? When we do the map name into name.to uppercase, right? We want to call the method to uppercase on the object that is the parameter of the lambda, okay? So this notation can do that as well. It doesn't have to be a static method accepting a single parameter. It can be an instance method accepting no parameters, in which case Java is going to be smart enough via parameter routing to determine that whatever string object I'm looking at in the map, I need to call two uppercase on it. So it becomes the target of the call to uppercase method.
I thought, in my opinion, was that we should specify object. If we can use this notation with objects, yes.
Yeah.
And I thought that we should specify object. But now, for me, it seems that this syntax uses like this argument, like implicit argument, yes, of the static method, of the method of the string class. Yeah, I understand.
Okay, so the remark was, well, I thought we could specify in this method reference syntax, an object on which a method would be called. And yes, you can. Okay, so that's something that we are going to look at again in a few slides. I don't remember exactly how many, but we are going to cover the three base cases that can happen here with method reference, and then we'll cover an extra one towards the end. Okay, but yes, there is a lot of work done automatically by Java for you, so it's good, and at the same time it's not good. Reason for which it's good: you look at this notation. Everybody in the class, I'm sure, you look at this, you understand it. You say, oh yes, I'm applying, two uppercase to every element of my stream. Let's move on, okay? But then there are subtleties, there are like different cases that you are going to only come to think as you try to apply this more and more, okay? Like for example, first reaction here was, well, hold on a minute. If you talk about the method to uppercase from the class string, is it a static method? Is it a non-static method, an instance method? Is this method taking one parameter? That would be ideal here, or 0. Is it taking multiple parameter? If it takes multiple parameter, where do I get my parameters from? Okay, so it's one of those things where when you read a tutorial on lambdas, and mapping and stuff like that, streams, it's so clear. The code is so beautifully clear that you can very easily be carried forward, and say, okay, this is trivial, I know how to use it now. But then there is always a lot of work done by Java behind the scene. And you need to understand at least, I would say a third, or half of what's happening behind the scene to be able to use that correctly. Because if you don't, then sooner or later, you're going to get one of those nice compiler error messages. And with Java 8, actually, the compiler error message got a little bit more, I would say, they got a little harder to decrypt sometimes. Okay, you're going to get some things that are really weird. It's kind of like when you start using JavaFX. Okay, like in an undergraduate class, you learn the Java programming language, you learn to deal with the compiler, you learn to understand why the compiler says some things at some moment, and then the first time you try to use JavaFX, you get that stack trace, that is like half a page long, and it takes you time to get used to those new genre of compiler error message, right? Same thing here, okay? But the worst you can do, by the way, with compiler error message, I tell that to all my undergraduate students, is learn to ignore them. And I see that with a lot of students, okay? The first time they get a compiler error message, it's missing some icon, they say, oh, that's helpful. Then they get something a little bit more weird, The compiler didn't lost track of what they were trying to do with their code, so they just decide that this point in time, the compiler is worthless. So they get an error on the compiler, and they say, well, something is wrong with my code, I'm going to change something. And they keep doing that almost randomly until the compiler shuts up. That's the last thing you want to do, okay? I know at your level you guys are probably not doing that, but you might be tempted when you see the error message you are going to get there. No, try to understand them, okay? And sometimes it's a bit of an investment, but it's worth it.
So,
Yep, sorry. Question?
The friends.string.
Yeah?
If I just want to store that in a variable, what would be the data type of that variable?
It's going to be a stream of strings. So the question is, when you call friends.stream, you get something, right? You get a stream out of it. So what if I want to store that stream in a variable? What would be the data type of the variable? In that case, that would be stream, uppercase S, of string. So that's a generic class, okay, that represent a stream of specific types of element. Now, this being said, again, okay, try to resist the temptation to store strings in variables and stuff like that. And I'm going to just give you one reason why, and then we'll keep going, okay? But when you have a stream here, okay, what was our primary motivation for using a stream? We wanted to get rid of the life cycle of that temporary collection. Okay, so now let's say that I store the stream in my variable. Well, it's kind of like I just created a collection, right? Except it's a stream, but I still manage it. So I create it, I store it in a variable, then eventually I'll get rid of, that variable. So you're kind of like, you're not really going too far backward, but you're kind of like, it's like the water is cold, you're putting your toe into functional programming, and you say, oh my God, this is cold, I'm going backward, right? No, go for it, okay? Try to embrace the functional programming style, or at least the part of functional programming that made it to Java 8, okay? It's not the purest functional programming, but it's still a significant change compared to the normal Java developer like we were all, like before the release of Java 8, okay? So that's the first thing. And then the second thing I will also mention is I told you guys that we have like some operations that are intermediary operation. Takes a stream, spits out a stream. And then we have some operations that are terminal, like for each. When you are done applying a terminal operation on a stream, you should not reuse that stream ever, ever, ever again. All right? Streams are meant to be disposable. So when you store your stream in a variable, what scares me is that you open the possibility that you are going to do friend.stream and you assign it to a variable, then you call on that variable map and you assign the result on another variable, and then you call for each, on that last variable to display the count, and then you say, hey, I want to compute the sum, so I'm going to call another terminal operation on that same variable to compute the sum of that stream. No, streams, and the name kind of convey that connotation, okay? Streams are ephemeral, they are transient. They are there just to be used one time, pass to the next step in your pipeline. They are a stream of water flowing through your pipeline, okay? Don't try to stop to hold the water. That becomes really philosophical. I mean, this is great. No, I'm kidding. So build your pipelines like that, your fluent chained call to method, like this. Generate a stream, do a bunch of intermediary operation on it, refine what you want to obtain, then do a terminal operation, and you're done. Question? Yeah?
You are taking the name as we just get the value from the specific object at that specific time. Is there a way to get the index?
What is your question about the index? I just missed that last part.
Yeah, so here we're getting, so when I do a map, an object dot map name to name dot length, so I get the length of each name.
Yeah?
In case, so if I'm mapping it, if I'm converting every name to uppercase in another case, so I'm not exactly changing the values in the. If I have a list and I'm using the map method on it, and I use name to uppercase, it's not going to change the values in my list.
No.
So in case I need an index to help change my values in the list at the same time.
Okay, so the question is, let me see if I can summarize it. It's more of a remark. The remark is, when we apply to uppercase with a map, we do not modify the original list. The answer is no, you do not modify the original list. When you apply name to name.length, it's just, now it makes sense because since you never modify the original list, you can spit out a stream of strings that have been changed to uppercase, or you can spit out something completely different, like a stream of integer value. Okay? So now the other remark that you had in your question was, well, if I want to go and modify things in the collection, I still need to use indexes. We're going to look at this really in probably 2 slides or something like that, okay? Just because the first time I looked at this is also something that bothered me. I wanted to be able to introduce my side effects, because otherwise I don't feel like a real programmer, right? If I don't have mutation all over the place. So we have an example of just that, okay? But this being said, again, I understand why you would be curious about that. I was curious too. It's not necessarily the right philosophical approach, okay? Like we keep talking about, questions where I tell you, yes, you could do that, but don't try to go that way, okay? Go functional as much as you can. That would be an example, okay? That's that's typical of when you discover those methods and you're not already a functional programmer. You want to do those things, but you have to, like, control yourself there. Yes, question.
I have a question. Some languages provide version of the map. Some languages provide version of the map that also can accept index of the element. Yeah, accept the value of the element. So in Java, we do not have such version of the function like in map or something.
No, not that I know of. So the question is, do we have a version of map in Java that would actually get not only the element name, but also its index? I've not looked for it, to be honest. I've not seen it in the examples I've studied. So I would say no, I don't think we have that. Okay.
So,
Yeah.
suppose I wanted to store the uppercase into another collection.
Okay.
So can I go like collection C is equal to new collection, and then in the parentheses I can go like friends.stream dot map name tends to name dot uppercase. That's it.
So the question is, well, that's nice, but what if I want to store my results somewhere? You just told us, don't store the stream. Okay, so I'm not going to store the stream, but I want to transform my friends list in uppercase, and I need that somewhere. I need that as a collection. So we are going to explore how to do that. Just to give you a heads up on it, we have a terminal operation called collect. So instead of doing for each, we do .collect, okay? And .collect, one of the application is exactly to do what you described. So that means .collect is going to take a stream as input, and then it's going to build for you a collection with all the elements of that stream in it. Make sense?
Yeah,
So that would allow you to store it to a variable, that would allow you to use it in a less functional programming way if you want. Do whatever you want with the collection. Okay?
yeah, the example that I just said, collection C is equal to new collection, then I'm passing the first.
Well, let's not go into the syntax of how we could do that before we cover it, okay? Because otherwise you are going to try to I mean, I don't know if you are basing your question on examples that you saw with collect, or if you are trying to reinvent the syntax that could do the job that collect does. Let me just get to that point and we'll see how collect work. And, that's pretty much, that's going to be the preferred way to do it in this style of programming. All right? Sounds like a plan? All right. So, and I lost my cursor apparently here. There we go. All right. So that's it. That's where we go to, but I don't want to be a functional programmer. So what about if we want to modify the original stream? So in this case, you guys already went into that. The friend list is not modified, okay? We made that clear. Reason why, there are different levels, okay, of reason. You could come at this and say, well, I know that a string object in Java is immutable, so I know you didn't modify the string object that I have in my collection. That's the first level. The second level is, well, you return a new string, from this lambda, but you never assign that reference inside the original collection. So that means that you didn't change the reference to the object that contains the first name in your list. So that, again, that's not something that is even possible. And actually, if I remember correctly, it's kind of a stretch, but if I remember correctly, we even defined our friends collection as final. So what does that mean, final? That doesn't mean that you cannot add and remove stuff. That just means that you cannot modify the reference themselves. So we have two levels of protection. We have the objects themselves, the strings, are immutable. And then we made our collection also immutable. So once it is initialized, originally initialized, it's done. It's set in stone, okay? So again, several levels, besides the fact that we use streams here, and this is like a facade on our collection, you could also infer that we didn't do that just by those angles, by those perspectives. So what if we want to modify things? Well, let's move away from string, because strings are immutable. Strings are immutable. So let's go back to employee. So we have a first name, a last name, a constructor. We have a toString method. None of that should be new. Then we have the block highlighted in yellow, which is called upWeGo. It's a method, instance method. All we do is we replace actually the string. So we don't mutate the string. We can't. It's immutable. But what we can do is we can actually mutate the fields. Okay, so we replace the reference in first name by the reference to a string that is actually the uppercase version of whatever string was before in first name, and then we do the same for last name. So we have finally side effects. We're going to be able to create some bugs for the next generation of programmer to be hired to solve. So how do we modify those employees? So we have a list of employees called employees, just like friends, okay? New empty array list. So this time we didn't declare it final, but we could have. Actually, no, we could not have because we built it without an initializer. We just built it with a loop. So after that, what we do is we do friends.forEach. So we use our list of names, okay, just to generate names for our employees. And for each element in the friends collection, we take the name, and we add to our employee list a new employee object with the name as first name, so the name that we got for the list friend, and the last name is going to be always Smith. So we create pretty much a list of employees from our list of friends. And then we apply the upWeGo method, so we don't even use streams here. There's no point, right? We are not going to transform temporary data structure. We just say, call the forEach method provided by the collection framework, okay? List of employees is a collection. Apply to each element of that collection the following Lambda expression. An employee is your parameter, and you call on that employee upWeGo. So you can have this kind of side effect. If you then display the employee collection, you are going to see that all the names have been actually modified to uppercase. Okay, so I don't think there's anything new here. We are not using streams at all. Okay, so the forEach here comes from the collection framework, and actually you can have forEach actually applicable also, and it doesn't show because it's at the bottom, but to anything that implements java.util iterable. So anything that can be iterated, you can use the forEach method on it. Yeah, question?
So in string, when we had to make it, just when you're at the previous slide, you're mapping it to uppercase, we use the string wrapper class for us for colon and to uppercase method. Can we use the same with upWeGo, as in I know my class is employee, because I haven't made it static, so I'm going to use it with reference.
Okay, so the question is, what about method references? Okay, in the previous slide, we use method reference to say string, colon, and then, what was it, to upper, or something like that? Okay, so we reference a method that was there without having to write a silly lambda that was boiling down to take a parameter, send it to that other method. Okay, so yes, you can use method reference here. The rule of thumb is everywhere you can use a lambda expression. If you have a method that can fit there, you can use it. Now, part of your question was something about, that method is not static. It doesn't matter. Okay, and we are going to cover that in great detail when we do parameter routing. Actually, I don't know if it's great detail. We're just going to cover the surface, so it's not great details. But we are going to at least cover the 3 base case plus another one. That's going to show you that all sorts of methods can be used in that context. And Java is actually quite smart about connecting the parameter where they belong. But you need to know the rules that Java is using so that you don't have misfires. Okay, so we're going to get to that too. So now the question is, was it a good idea? Okay, was it a good idea to try to modify the state? So spoiler alert, no, it was not that great of an idea. But what you have to understand is a trade-off, okay, that you are getting into. So the trade-off is, with functional programming, you have those benefits. Okay, so first benefit, we already saw that. You can create entire pipelines, multi-step pipeline of aggregate operation. The term that is used is fluent chaining of functions implementing intermediate operation like filter, mapping, stuff like that. And then terminal operation like forEach, we're going to see reduce, we're going to talk about collect. That's going to enable us to put things into collections, okay? We have lazy evaluation, which was also one of the questions that popped up, okay? And one of the things we didn't mention is that the dot stream method is actually very nice, because if you replace it by dot parallel stream, I'm making it sound a little bit too easy, okay? And there are a few things you need to be careful about. But if you replace friends.stream by friends.parallel stream, then suddenly what you get out of the collection friends is a stream, and you tell Java, oh, by the way, it's okay for you to try to multi-thread the processing of my pipeline. So anything you can do in parallel, do it. And that's where streams really shine, okay? We talked about that at the beginning of the class. Why are suddenly people so interested in functional programming? Functional programming, I'm going to say probably something stupid, but has been around probably around the 60s. Before that, I mean, the mathematical aspect of it were like lambda calculus and things that are even more ancient. But we have had, my point is that we have had Lisp family functional programming language since a very, very long time. So why is it that suddenly industry, okay, is paying attention to that? And the answer to that is parallelism, okay? People have come to the realization that it's hard enough to write code that is correct, but when you are writing concurrency code, it's really difficult to reproduce some bugs, they are transient. It's really difficult to do anything guaranteed there. So there has been a lot of research in trying to make, constructing concurrent programming that are actually more robust. Like think about going from implementing your own semaphores to actually using things like monitors, okay? And then there have been languages like Java that came, one of the big exciting things about Java was that it came with multi-threading support. It came with the idea that every single object in your application is going to pretty much behave like a monitor if you need it to, okay? And then, even with all of this, even with all of those high-level language, still difficult to write, correct concurrent application. So imagine that you make the effort, okay, to avoid side effect. You prevent yourself, you restrain yourself from having side effect inside your Lambda expression. You do it all like they tell you to do it, in those Java 8 book, and then for free, or almost for free, you can hit a switch and suddenly everything executes in parallel without you having to worry about any issue of synchronization or anything like that, okay? That's worth it. That's especially worth it in a world where the single individual cores of a processor are not improving that fast anymore. Moore's law is not applicable, has not been applicable for years to single cores. But what we do, we have multiple cores, more and more cores, right? Multiple cores are great, especially if you write a single thread Java application. Then you are going to see how it does not scale up to your new CPU, how it's still using one of those single core and staying well put in that core, and you completely miss all the advantage of the next generation of hardware, okay? So this is why all of those things are really getting to the front scene right now. And it's also an interesting lesson because functional programming used to be a computer scientist dream or a mathematician dream only. Nobody wanted to study that, for example, in IT. And now we are, even in IT, we get to that topic because it's really fundamental, okay? So hold on, 2 questions. Let's start here. I think you had your hand raised first.
I had 2 questions. The first one is, can you show us the example of parallel evaluation for our map for converting it to uppercase? Because that thing can be done parallelly.
So yes, later. The question is, can you show us an example of parallelism with those lambda? Yes, we'll get to that later. But for now, think about all the examples we covered. If you just replace dot stream by dot parallel stream, those examples are simple. They are not trapped there. They are going to work in parallel. Or at least you are going to enable the Java compiler to generate parallel code to handle it. So that would be a very basic example just to give you something to chew on, before we get to more detail. And then you had another question?
So my basic understanding of parallelism, as in if I make a parallel stream, and so if I have 3 objects, so all 3, my stream, I'm going to have parallel copies of the stream, 3 of them, and probably I'm going to use functions from every stream. Is that how it's going to be?
Okay, so what you are describing is your view of how the parallel stream are going to work. If you have 3 elements in a stream, all I can tell you is that you might have up to 3 threads that are forked actually in the JVM, each of them applying your map operation in parallel to one of the elements. Now, how many threads are there going to be? That's an implementation level thing. I am not aware of what algorithm they use to determine that, okay? Yeah.
Sorry, that gets me to my question.
Okay.
So in the previous question, we used an up-we-go method.
Yeah.
Basically, I'm modifying my object at that time. So at that time, will Java throw me a runtime concurrent modification exception? or is it not going to throw me an exception?
No, that's the whole point. So okay, so the question is, what if I modify objects, with like the up we go method? Then if it's done in parallel, is Java going to throw some sort of exception, concurrent modification exception, to tell me I should not do that? No, that's the beauty of encapsulating your collection into a stream, okay, and even better, a parallel stream, okay. Yeah, question?
Just to remark about this question, it's kind of you have data parallelism and like function or execution parallelism. And here pipeline, as I understand, it implements data parallelism. So it's like split your data on like one thread will process one amount of data, other will process another amount of data. So it's like independent modification.
Yeah, so the remark was, just for the recording, right? The remark was that all of that splitting of the original stream, in parallel streams is done for you by the Java API, and then your operations are applied in parallel, and if your operations are independent, it's even better. So you talked in your question about, what if I want to do the side effect? That's okay, but you reap the most benefit when you actually, again, follow the functional programming style, which is if your functions, if your Lambda expression that you are mapping to your parallel streams have no side effect, okay, and they are just returning a new value, then the new value, whenever it's ready, can be injected in the next stream, the output stream, right? So you see how the less side effects you have, the more worry-free is your conversion from sequential stream to parallel stream, okay? If you start injecting like a 2 uppercase side effect in 5 of your intermediary operation, I would be really careful about that pipeline, okay? But if you keep all of your side effects for the end, like you apply just really pure functional, steps, all along in the intermediary steps, and then you put everything in a collection so that if you want to do some side effect stuff, then you do it separately, then you kept the integrity of your pipeline as being almost purely functional programming. If you do that, then it's as easy as switching from stream to parallel stream. And then Java takes care of the parallelism. But the more you try to do side effects in your Lambda, etc., I would say the more you open the possibility, then you have to do things by yourself, by hand. Okay, and that's not what you want to do. Yeah.
I just thought.
Getting back to you in a minute.
In this pipeline, actually, we can have if Java smart enough, it actually can split pipeline on independent parts, and one parallel thread could process first part, start of the pipeline, and then throw at runtime element to other parallel, to the end of the pipeline. So it's not just data parallelism, it could be like processing parallelism pipeline version. So it's it's not like we have 10 elements, so it will be passed to the end of the pipeline. No, it's like by each element it will be processed and then returned to the next parallel thread. So it just myself.
Okay, just keep in mind that an extension of that, so you are going over, so that means that we split the streams, but that means also that there can be that's what I understand from what you were saying, there can be a differential delay in how a solution is spit out of any of the function that execute in parallel. And if that's what you had in mind, yes, absolutely. That means also that, by the way, when you allow Java to potentially parallel process your stream, okay, you are giving up on the idea of sequentiality, okay? So that means that, for example, if you had string 1, string 2, string 3 in your original collection, everything we've done so far, we assume the string was going to be the string 1, then 2, then 3, okay? It's just the same order, like you would get for a for each. If you do parallel streams, you have no guarantee that your map operation, if it's applied in parallel to string 1, string 2, string 3, you have no guarantee that the map operation will complete first for string 1, resulting in that result going into the output stream, then for string 2, then for string 3. It can happen completely differently, okay?
Yeah, but we can force dot order it. You can use, yes, in the stream API, we can dot order it. Even parallel,
yes.
You can order it.
Yes, there is a way in the Stream API to actually say you want to reestablish that order. But think about it. If you want absolutely to reestablish the order of a stream, that means that at least that part of your pipeline is not really great for for parallel processing. So yes, you can pretty much You can give information to Java, okay? You can tell Java, I want a parallel stream, which the Java compiler understands, okay, this guy wants me, to parallelize everything I can. Then you can say, okay, I want this part to be ordered, in which case the Java compiler is going to back off and say, all right, we need to respect the order. So it's either we do things in parallel and we synchronize, okay, or I stop the parallelism for that segment of my pipeline, okay, and so that I'm not going to mess around with the order. Again, I really don't know how reliable it would be to say I want a parallel stream and then do a few intermediary operation that exploits the parallelism and then suddenly say, suddenly I want an order. Because at that point, depending on the mappings you have done, you are far from your original collection. So what kind of order do you want? You can ask as a first step, from a parallel stream to maintain order. But that's pretty much asking, I don't want a parallel stream. But if you try to ask for order at the end, towards the end of your pipeline, it depends really what you are writing. We need to look at the code and figure it out case per case. Because if you map your, let's take the weirdest example, right? You take a stream of strings like friends, you flat map that stream, so maybe you generate multiple, strings for each string that was originally in the list, and then what? And then you want an order, but how do you define order? Okay, it's not going to be the original order because some of the original element disappeared, some have been replaced by multiple, so the only way I can see to guarantee that order would be to really, really synchronize everything, and you lose all benefit of parallelism. So if you are in a situation like that, try to identify which operation can be actually parallelized and put them in a pipeline where you use a parallel stream. And then once you're done, collect your result in a collection and then maybe process that collection in whatever order you see is relevant. See what I mean?
Yeah, but still I suppose, I'm not sure that you have positive effect if you use parallel and then order. It's better than just to use sequential execution.
Yeah.
Because still you have some parts of the execution in parallel, but then Java synchronizes, you say it like it.
Yeah, so the remark was, I still think it's better, to use parallel, and even if you have to order at some point. And yes, the idea is that the compiler will definitely do its best to find a way to parallelize everything it can, okay? When you use a parallel stream, you are giving license to Java to try to find, the optimal way of executing your code in parallel, okay? You had a question too?
Yeah, what is lazy evaluation?
What is what?
Lazy evaluations.
Okay, so we are going to have another section on that, okay? But for now, just to give you a simplistic overview, like a bite, for now, think about an infinite stream. If you have an infinite stream, for example, you build up a stream that generates Fibonacci numbers. That can go on and on and on and on, okay? So, see, if you have such a stream and you say, you apply a function to that stream. Well, in traditional programming, that means you iterate over everything. So you iterate over the infinite stream, you apply your function, to each element. So you never end, because the stream never ends, okay? Lazy evaluation allows you to actually get something out of the stream only when you are ready to consume it. So I know it's a little vague as an explanation right now, but we are going to have an entire session dedicated to lazy evaluation, so bear with me for now. But that's the idea is that you want to not have your producers pretty much produce things that you're not going to use. Okay, that's a very, very general idea. I cannot do better, without getting into slides about that.
I recall Haskell. There is a phrase about Haskell. Haskell is very lazy language, and it's like writing the code in the Haskell. It's like driving the car, and you think you are driving the car, but actually you do not drive the car. It's like in your imagination, something like this.
Okay, I've never heard that one, but okay, that's just a joke about Haskell. No, but it's interesting. It's really it's one of those things that are conceptually new. Okay, when you go from imperative procedural programming to functional programming. Okay, and just as a side remark, even no matter if you are like a full-time developer or you just use programming, to write scripts as a sysadmin or stuff like that, one of the things that's going to benefit you the most in terms of learning languages is learning very different languages. okay? Like things like, for example, Haskell, closure, things that are more purely functional. Closure is not pure, but it's still better than this. Scala, try to learn different languages, okay? OOP, functional, declarative, logic programming. I'm pretty sure none of you ever touched a Prolog interpreter. A little bit? Yeah? Oh, wow, I'm surprised, actually. You guys make me feel younger. Great. Okay, but bottom line is that it's one of those things that if you ask nowadays, does an IT professional need to learn Prolog? Everybody's going to laugh at you. Just the same way that people 10 years ago were laughing at an IT program if you were even talking about introducing Lisp, a functional programming language. Nowadays, functional programming, people realize that it has its advantage, and guess what? One of the JVM language that has been emerging like the past years, named Clojure, is actually a Lisp dialect. So be careful when people tell you, you don't need to know that, you don't need to know this is theoretical, this is the... Yes, sure. Know the stuff, understand the concept, at least the base of it, okay? And then you can decide for yourself if you need more or not. But saying I'm not going to at all look into logic programming because I'll never use that, it's a bad bet, especially in a field like IT that changes a lot, okay? All right, the bad side of it is, yes, all of us said, parallelism for free. I'm just trying to get my cells up, right? You're going to get parallelism for free. You're going to get lazy evaluation, even though we don't know yet what it is. It sounds great, right? So all of these are like sales point. But now you have a price to pay for that. And I already insisted on that, so I'm going to go fast on this slide. But you have to adopt the functional programming style to be able to reap those benefits. Okay? So immutability, try to avoid mutating state in objects. Okay? Statelessness, again, it's about maintaining your state. Make sure that you can actually just apply a function on an object and get a new object out of it. That's the perfect scenario for functional programming in an OOP language, right? It's a new object. You don't have to worry about you are maybe screwing the state of the previous object, okay? And then the golden rule for the simple things that we're going to do in this class with this API, it's do not reuse your streams. Okay, it almost sounds like a do not reuse needle campaign. Okay, it's really bad. Okay, do not do that. Otherwise, you are going to probably you're going to get an exception at runtime anyway, assuming the compiler lets you get away with it. But I wouldn't even test it. Okay, so in exam situation, if I try to push you towards reusing a stream, it's a trap. Don't fall for it. Okay, we talked about it already 5 times. Okay, we have a few minutes left, so we should be able to just go through reusing Lambda expressions. So let's have a quick look. So we talked about right now writing Lambda expression. And every time we write a Lambda expression, we go from that style of programming at the top, okay, which is an enhanced for loop, to that style of programming at the bottom. So first use here of collect, but we are going to talk about it more and in more details, next session, okay? But right now, what we do here, for example, we generate a stream on friends. We filter, so that's a new intermediary operation. It takes a lambda, and that lambda expression is going to return true or false based on the name, okay? So in this case, I'm just using the starts with method from the string class, pass as parameter n, and I'm trying to detect names that start with n, okay? And then the terminal operation on that pipeline is collect, and we are going to go over the syntax, later, but right now, collectors.toList, there are a bunch of static methods in the collectors class that allow me to tell you what collection I want as a result. So here, I want a list, okay? So bottom line is I take all the names, I filter the names that are starting with n, and then I put them in a collection, and then I can display here the size of the collection, I can display the whole collection, I can do whatever I want with it, okay? So that's the operation, that's the pipeline. Hold on, I'm going to finish that example, then I'll go back to your question. That's the pipeline we are trying to build, okay? And then, here's our problem. We have 3 different lists of names. Friends, editors, and comrades. And we want to apply the same pipeline to the 3 of them. So what is it going to look like? It's going to look something like this, okay? So we have, remember, the point of the pipeline was to count, right? names we have. So we modified slightly the pipeline here. We used an over terminal operation, that's count. So it is going to expect actually a stream, and it's going to tell you how many elements are in that stream. Okay? So we just modified that part, but it's not a big deal. We have the same thing with friends, editors, and comrade. We compute 3 different strings. We repeat every time the lambda expression. So guess what we want to do? We want to take those lambda expression, and we want to store them somewhere else. So sooner you were talking about, can I store in a stream? I would say try to avoid storing a stream in a stream variable, okay? But can I store a lambda expression? Yes, absolutely, and you should, because lambda expressions are meant to be assigned to variable, pass as parameter, and stuff like that. So what you need to pay attention to here is, well, first let's go blurry on the first line, okay? What is in yellow is my lambda expression. I somehow store it into a variable named starts with n. And then let's look at the usage of that, okay? I can build the pipeline, and everywhere I was using my lambda expression, I just use starts with n. So I still pass the lambda expression. It's just temporarily stored in a variable. Now, what is the type of that variable? That's where it's interesting. Lambda expression implement functional interfaces. So we have a bunch of functional interfaces that are defined in Java 8. Okay, and that say, for example, well, this functional interface represents a function that, for example, takes no parameter, produce something, or takes one parameter, produces nothing, or takes one parameter, produces one result. Okay, so we have a bunch of different interfaces that define those archetype of function. Well, this is one of them. Predicate of string. It's a generic interface, okay? Predicate means that it's going to test something and it's going to return true or false. So when you have a predicate of string, that means that this is going to be a lambda expression that takes a string as parameter, so in our case that's name, and returns true or false based on what it finds in that name, okay? So again, I'm giving you references. I'm going to try to wrap this up to make sure we're in time, and then I'll get your question afterward, okay? But just to make sure you understand, there are a ton of functional interfaces. Well, not a ton, but there are a few, okay? So I'm giving you like references on the Canvas site and in the slide to website that you should definitely bookmark so that you can access, the catalog whenever you need it. How can we use this? Well, we can do the following, okay? So we have 3 variables. We have 2 variables here. We assign to each of them a different lambda. One that uses n and one that uses b to test, what's at the beginning of the name. And then when I use my pipelines here, I can decide to pass one or the other. It's just that easy, okay? Last step we're going to cover today, closure. And that's a very important one. So this is a fun stuff. This is how you're going to be able to write functional code in Java 8 that looks like actually functional code, okay? Let's take a look at this method here. Check if starts with. It takes a parameter. The parameter is a letter. Okay. So what I want to do is I want to give to that method a letter as a string, n or b for consistency with our example. And this method returns what? This is a lambda expression. This method returns a function. Okay? This function takes a string and then tests if it starts with whatever letter as specified here. So this, when I call check if starts with, I'm not checking things. I'm asking for a method. Give me a function, give me a method that is going to be able to test if something, a string, starts with that letter. Okay? That's why the return type here is predicate of string. You return to me a lambda. You return to me a predicate that takes a string as parameter. Okay? So this is pretty much what is mentioned there. And that's actually close to the idea of metaprogramming. Okay? In a way, at runtime, we call a method, and what we get out of it is code, right? A function. So it's simpler than all the metaprogramming we've done before. It's more elegant, it's cleaner, and it's a lot usable and useful. Okay? So how would we use this? Well, we would do stuff like that. Okay? When I call my filter intermediary step, I want a lambda. I call a method that's going to return to me a lambda. So I say return to me a lambda that checks if a word starts with N, or return to me a lambda that checks if a word starts with B. Okay? Pretty clean, and again, pretty meta. Last thing, what about we go one step further? Okay, so we're going to try to generate that lambda that we use from another lambda. So the reasoning for that, the benefit for that is that in the previous example we had a static method, okay? Well, we had a static method that was pretty much polluting our code because maybe we just need it, in that specific part of my code, but I had to define it as a static method. Okay, fine, I'll go ahead. I'll define it as a static method. Where do I define it? Where is the class to all my utility, static methods like that? So suddenly you have like some utility classes that pop up all over your code that really do not belong. Okay, so this is the same motivation that we had originally with Lambda. So what we're going to try to do here, we're going to say, all right, so I'm going to store in a variable name starts with letter, okay, something. That something is a function. So we saw predicate. Function is another functional interface. It takes a string as parameter. It returns a predicate that also takes a string. So it returns a function that takes a string, return true or false. So here's my parameter, so a string letter, okay? And then what I return here, I'm going to store it temporarily in a variable check start. So I'm going to return a predicate of string. So that's the type of check start. Here's my predicate. Take a string, name, and then test if it starts with the letter, okay? And then return check start. And then the rest is just closing the curly brace, okay? So we stop here. We're going to restart here next time, okay? But I really, really ask you to spend the time to absorb this example, okay? Play with it, run it. You can come in, we're almost done. Play with it, run it, okay? It's actually where it gets fun, actually, to handle Lambdas, okay? So take the time to read it, absorb it, post your question on the forum. And yes, we just wrote code that generates code, and all of that at runtime. So this is where functional programming, really shows its power. If you wanted to do that with those meta-programming techniques that we studied, that would be, at the very least, a burden, okay? So hold on to your question for 1 more minute. I'm going to start the upload because I need that to finish before the next class starts, and then I will answer your question.